Okay, so this is the first video on this text analysis project, and I've got the intro text analysis.rmd file opened up here. It's going to be using a package mainly called Tidy Text. I don't know what it is with R people and everything has to be tidy something, but it's a really nice package for doing text analysis. Um, the other thing I'm going to use this package Read Excel, which Excel is it's a spreadsheet and it's commonly used to create data sets that you then bring into R. The typical way that, at least that I've done it in the past, is I will save the data in the Excel file as like a CSV, a comma separated value, or a TSV is tab separated values, or some other text file that R can easily read. But I just wanted to show you this Read Excel will allow you to read the raw Excel file in without having to convert it or anything like that. So I just thought I'd show you this package. You don't necessarily need it for text analysis or anything, but it's just another way of reading in data. Um, I kind of must have been in a little bit of a morbid mood or something because the data I'm going to be using for this text analysis, the one in this project here, it's this suicide notes, and I got a number of mainly famous people's suicide notes that I found on the internet and put them in this Excel file. The project that I'll want you to do, the notebook that I want you to kind of start from scratch, is called Manifestos here, and it's a set of writings from mass killers. So people who killed a bunch of people and then wrote about their why they did it, and then found those on the internet. People like the Unabomber. So let's go ahead and load these packages in first. And we're going to be doing this suicide notes, and here are the six authors: Virginia Woolf, the famous author who committed suicide; Kurt Cobain. This O.J. Simpson one is kind of interesting because, of course, he did not commit suicide. But he wrote the suicide note and threatened to commit suicide and then didn't go through with it. And I think this Anthony, I forget the name, but it's the father, I think, of Casey Anthony. Anyway, a couple of other ones. And you can see that right now it's just in a big, in fact, yeah, you can even see the whole suicide note there if you kind of hover your mouse pointer over it. Some of them are a little longer, some of them are shorter, but I try to find ones that were reasonably lengthy to analyze. So we're going to be using these suicide notes for this initial analysis. I've seen. I think it's something that may be surprising that you can do quantitative analysis of text. It just doesn't seem like the kind of data that you could do, statistics on. But I've seen a lot of interesting analyses. I just was thinking about one that I saw the other day. It was looking at State of the Union addresses by presidents, presidential speeches, and showing how over time, like a long period of 150 years or something, or maybe even the whole history of the country, they had the speeches, and showed how over time they have gotten less complex, shorter words and just shorter sentences and things like that. Um, People have done text analysis to try to determine deceit, like who is lying. I've seen, text analysis, of course, of children's word usage so that they can figure out what kind of vocabulary the kid has, all kinds of stuff like that. Um, so anyway, once you read in these suicide notes, it's just a big string of text right now, and we need to do a little preparation in order to analyze it. And we're going to use this unnest tokens to do most of the setup. And what this will do, so it'll take these lines of words and it'll set it up into what's called a tidy format, meaning a tidy format means that each row of the data has an observation. And in this case, we're going to be analyzing words. So what it'll do is it'll separate or unnest these long passages and set it up so that each word is on a different row. And it'll do a couple of other things. It'll also, like, it'll take words that are capitalized and make all the words lowercase, so that we can, like if the word dearest is here and it's capitalized and we want to count the number of times the word dearest appears, if it appears later and it's not a capital D, well, those are really the same word, and so we don't want to make it. We don't want to count those as separate words. So it makes everything lowercase, so we can combine them all together easily. It'll get rid of the punctuation as well, and and it does that in just this unnest tokens line. If you look, our initial data set has the column called text that has all of the suicide notes in it. And so that's the second word of this unnest tokens command. And then the first word is what we want to call the column of words. So we could call it words or tokens or something like that. So if we run this, so you can see, if we look at the Virginia Woolf note, which is this first one here, dearest, I feel certain that I'm going mad again, and then you can see what it does is it puts each word on a separate line. Dearest, I feel certain that, and a lowercase I, and then if we kind of go through here, so that first one is Virginia Woolf, but then it goes to the Kurt Cobain suicide note, etc. So I thought we'd first do some basic analyses of kind of the complexity of the text. And so, for example, so we're going to take these suicide words. So we started with suicide notes, we converted into words and called that suicide words. And we are going to group it by author. So we want to keep the authors separate. And then we're going to count the number of words just with this N. It just counts the number of rows, so that's the number of words. We'll call that num words. And then also, there's a lot of repetition of the words, like the word the will appear a whole bunch of times. And so to get a better measure of what's called lexical diversity, we can look at the number of distinct words that are used. And so that's what this N distinct does. So that'll create a little table, and we can see, Kurt Cobain's suicide note had 574 words, and only 284 of them were distinct words. So that means, it's about half of them were repetitions of, the same word multiple times. And you can see Virginia Woolf, who was a great writer, she had 194 words, and 100 of them were distinct words. And so actually we can get a ratio here, like what proportion of the words were distinct words, and that's called lexical density. And so all we're doing is we look, if we look here, we've got number of words and then lexical diversity, or number of distinct words. And if we want to add the ratio to that, we just add this lexical density and its number of distinct words divided by the total number of words. So kind of only thing that's doing is it's adding a new column with a ratio here. So it's kind of a measure of the, you can see Virginia Woolf, about, what is that, 52% of the words that she used were distinct words, whereas this Anthony, I think, was the lowest, and that was only 32%. So a lot of repetition in that statement. Seems a little weird to do this with suicide notes, I know, but I mean, usually, they might do this with, like I was talking about, the State of the Union speeches to get a sense of the complexity, of the speech. So I say the number, another measure related to verbal complexity is the length of the words, so the number of characters, and we can do that with this nchar, the number of characters command. And so we're going to create a new column called word length, and then we're going to look at each of the distinct words and look at their word length, and we're going to sort them in descending order by the longest word. And so you can see unappreciative, which has 14 words, hypocritically, respectability, those all have 14 words. And if we go down, there's words with 10, 7. Let's see if we go all the way. Words with 4, you know, etc. Okay. And then what we can do is we can get the average word length for each author. And so we're going to group by author, then do the same thing that we did above with it, count the number of characters, and then this is new. We're going to summarize it by getting the mean of the word length, and then sorting those like we did above. And so you can see it's interesting that Kurt Cobain had the longest word length, the longest average word length, but they're all pretty similar from 3 to 4, 3.5 to 4. Now, the next step here is we're taking basically the same thing that we did above here, but we're going to create a plot of it, and kind of basically a histogram of the word lengths for all of the notes. And so you can see, you know, typically we're going to get word lengths of, what is that, around 3 or 4 words, right? And then there's you know, a lot of words that have 1 or 2, like and the, and of, you know, words like that are common. And then relatively uncommon are words with, you know, above 10 characters. So, okay, so it says recreate the above graph, but then make these 2 additions. So I'm going to go ahead and copy this. And then it says add the following line, so I'll make sure you put the plus sign, and I'm going to do this facet wrap, and then the variables that are going to be wrapped, and I'll show you what that means. Author. So what we're going to do is create a bunch of mini graphs for each author. Do the same thing, but instead of for everybody, do it for each individual note. And then scales equal free y, and then another line with a title. So whoops, let's see, title equals, and then we'll call it word length distributions of suicide notes. Let's say by author. Okay, let's see if that works. So this is, I like this facet wrap. It's kind of a cool function because what it'll do is it'll take your graph that you made up here, and then whatever other variable that you give it, in this case author, it'll make a bunch of mini graphs of each of the elements in that variable. And so you can kind of look at it and see they all kind of look the same. They're definitely skewed, you know, so that you have a lot of short words and relatively fewer long words. But you might look and see how different authors have different, you know, distributions. Okay, so that's some pretty basic stuff. Here's some more basic stuff where we're just going to count the number of the most common words that are used. So we can just take our suicide words and put it into count the words, and then we're going to sort it. And so we can see through all the notes, the most common word was I, and then to, you, the, and, etc. And it makes sense. These are, you know, just common words. And then we can group that by author. So it says take this and copy it, and then just add this line, group by, and so we just want to group it by author so we can see the different common words for each of the different authors. Okay, so there it shows you the author as well. And then we can make, this is a little hard to read, so we can make it into a nice little graph. And so it says, graph the most common words by copy pasting the above code on top of the following. So what I'm going to do, so this is kind of figuring out what the most common words are. So I'm going to take this, copy it, and then feed it into this. It's this kind of a long thing. It's actually more it's not it's simpler than it looks. I've got a lot of things here that are kind of just making the graphs look prettier, but uh, basically I'm just making a graph, and then make sure you put the, when you paste this in there, that you put the pipe in there. But basically it's going to take the top 5 most common words of each author. It's going to make the plot. It's going to flip the coordinates. It's going to do that facet wrap so we get one graph for each author. This creates a new, a different color scheme than the default. This gets rid of the gray background, and this puts the title on it. So let's run that. Okay, so there you can see what the most common words are for each author. And they're all pretty much the same. I and you and the. And so this is a problem. So we've got all these really common words, and it doesn't really tell us that much. And so a common thing that we do in text analysis is we remove those common words that are called stop words. So again, words like the. And we can, the Tidytext package comes with these a stop words dictionary. And so we can take a look at that by, first of all, getting them, called get stop words, putting them into an object called stop words, and then looking at all the words. And so you can see there are about, what is that, about 200 or not even 175 of them. And words like I, me, you, your, or, by, at, etc. And so what we want to do is get rid of these and keep the more interesting words, the nouns that they use that are, that are uh, more than just these common words. And so to do that, we use this anti-join. And this is kind of the opposite of join. If you join two data sets, then you're just going to put them together. Anti-join will take the words that the two data sets have in common and remove them. And so that works perfect for this, because what we want to do is take our suicide notes and then remove these words from them and then analyze them after that. So we'll say suicide words and then anti-join them with stop words. And so what'll be left here, so if you notice, so dearest, feel certain, going mad. So if we go back and look at the original, where was that? The Virginia Woolf suicide note. Where was that? Oh, maybe I didn't display it. But anyway, I think it said, dearest, I feel certain that I am going mad, something like that. And you can see that it removed those kind of uninteresting words, the stop words, and just leaves these. And so, excuse me, so it says to count these words, copy paste the above code. So we just want to make sure we're not going to save this into a new data set. We'll just, every time we want to remove the stop words, we'll just execute those commands. And then it says pipe it into the following line, count word. So it's the same thing that we did above, except now we're counting the words with all of those stop words removed. And so now, instead of I and the, we get some of these more interesting words, love and know and people. And then we do the same thing, but adding this group by author line here. So just exactly the same as above, but with this line here added. And so we can see, the most common words for each of the authors. And so just like we did before, I have this code here. I think it's exactly the same as above to make those individual graphs. But now we're going to copy this with this anti-join of the stop words. So basically removing the stop words first, and then make sure we add the pipe there. And remember, it's Command Shift M or Control Shift M will do this little symbol. Okay, so same as above, make a bunch of little graphs, but we're going to remove the stop words first. So let's do that. And so there you can see it's really different, right? So now we're getting, so just to remind ourselves of what it was above. So I, you, to, her, I, to, and, the, of. Those are the words like Kurt Cobain's most common words were I, to, and, the, and of. And now with those words removed, those were all stop words, I think. So look how different it is. Love, much, people, good, empathy, feel. Really different, kind of much more meaty, interesting words that are left. And so you can see why this is commonly done when you do text analysis. By the way, not all of them are 5. It's supposed to be the top 5, but it'll take ties. So you can see with Virginia Woolf, she didn't have much repetition, so her most common word was only used 3 times. And then after that, there are a whole bunch of words that were used twice. And so it keeps all of those ties in. Okay, now here's another statistic that we can do on text, and it's called TF-IDF. It stands for term frequency dash inverse document frequency, and it's you can read this here, and there's actually a kind of a whole chapter in the book. There's this book called Tidy Text Mining that is kind of almost like a manual of that tidy text package, and it's devoted to this measure called TF-IDF. But basically, it's a measure of the importance of that, the importance of a word compared to the other documents. So how important is a word in one document, like one suicide note, compared to all the other suicide notes? And if let's say the word um, you know uh, uh, death appears in all of the suicide notes. I don't think that's true, but let's just hypothetically, let's say that the word death appears in all those suicide notes, then it's not going to come out as important in any given one. It'll because it's so common. And so it's a way of looking at just the unique words for one document in comparison to the other documents. And so I kind of give you a little explanation of it, and you can read that, but let's just leave it at that for this video. But this code here, this whole chunk here, calculates this TF-IDF. It's a couple of different steps here, and kind of intermediate calculations that I wanted to show you. It actually, if you notice, it starts with suicide notes rather than words, and then does this so it kind of goes backwards a little bit and redoes some of what we've already done. Only reason I did that is so if you wanted to do this analysis starting from the beginning, without having to do the stuff that we did above, then this will do the whole thing. So it repeats a little bit of what we did above. But let's just go ahead and do that. And take a look at the output. So you can see, like, let's take this Craddock had the word deer over and over again, and so that one word deer appeared 16 times in his suicide note, and the suicide note was 1,037 words total. And so this TF, term frequency, so that's how often does that word appear in that document. So you can see, a little over 10 divided by 1,000 is a little over 1%. And so that's that 0.015 here. That's basically the proportion of total words that are this one word deer. The inverse document frequency, it's a measure of how often the word occurs in the other documents, and then this TF-IDF is basically just this number times this number. And if you do that math, basically it's 0.01 times something close to 2, and you can see you get something like 0.02. And so this TF-IDF is a measure of how important this word, like this word deer, appeared you know, a ton of times in this one note, but I don't think very often in the other notes. And so that has a very high TF-IDF. And so what we can do to kind of get a good look at this, a better look than this table gives us, is to do the similar graph that we did above. And so it's going to take that TF-IDF. So if we look, the final product of this big chunk here was this suicide TF-IDF. And so we can take that and basically graph it, and we're going to use this facet wrap to graph each author's important words. So just run that. And so see, it's similar to that analysis above. It actually is pretty similar to removing the stop words, which are common words, and then graphing the words that are left. It should be pretty similar. I mean, so if we look at Kurt Cobain again, empathy, much, love, people, good, feel, that's where we just removed the stop words and looked at the most common words that were left. And if we use this TF-IDF process, well, it's not, I mean, the word empathy, but like appreciate wasn't in there, so it's a little different. It's just a kind of, but it's a little bit of a different measure of, like if we look at the word love appeared here, but love also appeared in some of these other ones, like this note here, it appeared, the O.J. Simpson one, this whale, it was a popular one in his note, right? So this word love was not unique to Kurt Cobain's document, which is why it didn't appear in this TF-IDF, right? So it only selects words that are common in one note, but not common in the other ones. So it's just kind of gives a little bit of a sense of what's unique about that document. And you can kind of see, agony and nerves and pills. You can kind of see what the subject matter, the unique subject matter of each note was. And you can see this Anthony, who's all about the people, Marie, Kaylee, Casey, Cynthia, etc. Okay, so then it says, let's clean up the graph a little bit. So let's go ahead and copy this. And then add a few things. So I'm going to put the plus sign. It says do theme minimal. And then the scale fill viridis. And it says viridis D, which stands for discrete. It's when you have, so these are discrete words as opposed to, individual, or no, I think it's the discrete differences between the authors as opposed to continuous. If it's continuous, so you might have noticed it had scale fill viridis C was another one, and that's if you have continuous data like shades of green or something like that. Okay, so scale fill viridis D, and then let's add this title, and then it says most distinctive words in each suicide note. Okay, and so that should, see if that works. So it just kind of makes it look a little nicer than this one. Okay, so that's the basics. Now, the assignment is pretty much do what we did above, but use these manifestos. And this is a pretty grim data set too. I don't know why I picked these, but these are all these killers who wrote stuff, and then I found them online and stuck them into the data set under manifestos. So okay, I'll go ahead and stop there.